It's ready. Hello, students, and welcome to today's Friday Happy Math Hour. Today we're going to be covering, I believe, it's chapter 5 from the Math 1324 book, which is simple and compound interest. In annuities, simple compound interest annuities. Okay, so these are the 4 topics that I'm going to cover. Simple interest is from 5.1. Compound interest is from 5.2. Future value annuities is 5.3, and present value annuities is 5.4. If you guys have a calculator, preferably a TID3, TID4, I'm going to show you how to use it also in on this PowerPoint here. Okay, so let's first start with simple interest. This is a formula for simple interest. I believe in the book, it just has an I equals to PVRT, but I use INT for interest. Let me tell you what everything is. The interest is a fee paid to use someone else's money. The PV stands for present value or the principal. The R stands for the interest rate. And the key thing here that is always in a percent, there's a percent symbol by the by the coefficient or the number. And time is always in years. Okay, now there's 2 formulas that we're going to be using here. Okay, for example, if we get the interest, right? If we get the INT, the interest for the future value is equal to PV, which is a present value plus the interest. But from this formula here, the future value equals to present value plus the interest. I'm going to come out with another formula. Okay, so let me show you how we do that. The interest, right, is PVRT. So I'm going to substitute PVRT for the interest formula. Now I'm going to factor out what they have in common between the PV and the PVRT terms. Right, so they have in common a PV, so I'm going to factor it out. So what's left? 1 plus RT. These are the 2 formulas that are going to be used in this section here. And again here, the key word is simple interest. And for this one, the FE stands for the future value, the sum of the principal and the interest earned, which is a future value. The PV stands again for present value or the principal. The R stands for the interest rate, and the T stands for time in years. So let's do an example, okay? But before we do that, this is what you need to know. If months are given, right? Say, for example, the problem doesn't give you years, it gives you months. So then you have to write down the given months over 12 for the time. And also the interest rate must be in decimal. For example, 5% is equal to 0.05. So you take away the symbol and you move the decimal point 2 places to the left. Or you can divide the interest by 100 and take away the symbol. So example, 5% is equal to 0.05. Okay, these are the 2 things where a lot of students make mistakes. So make sure that you know exactly how to apply the time in years and the interest rate as a decimal point. Now, example, example 1. Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle, and how much interest did Martha pay? So which formula are we going to use? Is it the interest equals to the present value times the interest rate times time, or is it the future value equals to PV 1 plus R times T? Does it matter? No, it doesn't. Okay, I'm going to do this example. I'm going to do it by using both formulas. This one on the left, and also the one for the future value. Okay, so let me start first with the interest equal to the present value interest rate times time. So then if I use this one here, the interest formula, then I have to use the FV equals to PV plus INT, because the future value is a present value plus the interest. Okay, so let's do the example here. So this is what I tell my students to write down. You have to write every variable that's in the formula. Then they're going to give you every variable except for one, what you're looking for. So what I tell my students, if you set it up this way, the way I have it here, if you're able to extract all the information from the word problem, I will not deduct that many points if the answer is wrong, because in my opinion, is not correct if you got the answer wrong and everything is wrong, right? But for the homework, if the answer is wrong, everything will be wrong on my math lab. But like I said, the way I do it in the exams, I tell my students to write all the variables down and extract the information, and they'll get most of the points. So let's see what they have here. It says Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest of 3.5% for 5 years. Find the total amount that Martha paid to her uncle. And how much interest did Martha pay? So for example, here guys, find the total amount that Martha paid to her uncle. We're looking for the future value, right? How much did Martha end up paying to her uncle in 5 years? And also, how much interest did Martha pay? So if we use the interest formula, then we're going to find out first what Martha paid. Okay, so here, guys, we have to extract the information, right? So the 12,000 is the present value, how much Martha borrowed. The interest rate, right? The R is the interest rate is always very simple to observe because it's the number with a percent symbol. So it's going to be 3.5%. Now you can divide this by 100 and drop the symbol, or move the decimal place 2 places to the left. So it's going to be 0.035. That's my interest rate. Now the time, right, is already in years, so the time is going to be 5. So all we do here, guys, is write the formula down and plug in all the variables, right? My PV is 12,000. My interest rate, the R, is 0.035, and my T is 5. So all you do is use a calculator and you get your answer. So the answer is 2,100. So that's how much interest Martha paid, but we're also looking for the future value. So the future value will be the amount that Martha borrowed plus the interest. So the amount that Martha borrowed was 12,000 plus the interest, which was 2,100. So we add them up and they'll give us 14,100. So to answer the question properly, the total Martha paid was, right, $14,100, and the interest paid was 2,100. So this is the correct answers for number 1 here. Now I'm going to use this very same problem, but instead of using this formula, the interest, the INT equals to PVRT, I'm going to use the other one that we use, right? That was the second choice. So now this one here is going to give us the first part of the question, right? Find the total amount. So this will find us the total amount in 5 years. So then we'll use this one then to find the future value. To find the interest, we subtract the present value from the future value, which I'm going to do after I get this. After I find the answer for this one here. So again, my present value is 12,000. My interest rate will be 0.035, and the time will be 5. So we plug into the formula, right? There's my present value. There's my 1 plus my interest rate plus the times the time. Use your calculator. So I get 14,100. So if you're going to use this formula, this future value formula, then to find the interest, we subtract the present value from the future value. So it'll be 14,100 minus the 12,000, right? Because this is a present value. So you see, guys, we get the same answer as we did on the previous slide. Okay, so Martha paid 14,100, and the interest paid was 2,100. And like I said, a lot of times students have a hard time to decide what formula to use. So I tell my students, you guys use whatever is easier for you, okay? Because we all think different. But just make sure that you know how to use a formula. And if you use this one here, right, the future value, then to find the interest, you subtract the present value from the future value. If you use the other one, right, in the previous slide, the interest is equal to PVRT, then to find the future value is equal to the present value plus the interest. Okay, let's do another example. So it says here, Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25 simple interest to have enough money to pay the tuition bill? Again, here the key word, right, is simple interest. So we know it's going to be the formulas that we used earlier. Okay, now what formula should we use? So check this out, guys. So we're going to use this one here, okay? Because here, Mariana will need to pay a tuition bill of 7,500 in 10 months. So this is the future value, right? So this is the future value. So in this case, right, we're looking for the present value, right? Because it says what dollar amount can she deposit today? Today means the present value. So the future value will be 7,500. The interest rate will be 1.25%, but we have to put it as a decimal, right? So we divide it by 100 or move the decimal place 2 places to the left. And we drop the symbol, the percent symbol. So it's going to be 0.0125. If you notice, that time is in months, right? Here's a common mistake that students make. They put 10 for time, which is not correct because the time has to be in months. I mean, it has to be in years, I'm sorry, in years. So it's going to be 10 divided by 12. Now from there, right, we have only one unknown, so we can plug everything in the formula. Right, okay, now, the book and also my math lab, they want you to use this formula to find the present value. Because how did they get this formula, right? So all they did was divide both sides by 1 plus r times t. That's why PV is equal to future value 1 plus r times t. I want to show you how to do it this way, right? But then I'm going to show you how to do it another way. The other way is much more student friendly for students that don't know how to use a calculator. So I'm going to use this method first, and then I'm going to use the other way by using a TI-83, TI-84 calculator. Okay, so if we do it this way, right? We plug everything in. This is my future value, which is a 7,500. We have 1 plus r, right? R is 0.0125 times t is 10 over 12. If you guys know how to use a calculator, you can put all this, right, in one shot, for example, but you have to put parentheses for the numerator and parentheses for the denominator, or else it's going to be wrong. Okay, so anyway, we first have to do the bottom part, right, because on the numerator, it's already 7,500. So if we put 1 plus 0.0125 times 10 over 12 in the calculator, it should give us 1.01041667. Then then you have to stop the calculator and then enter the 7,500 and divide it by what we just got here in the denominator. So that's my answer, 7,422 and 0.68041. But on the homework, they want you to round off to a nearest penny, which is to the nearest hundredth. So we look at the third place. If the third decimal place is less than 5, right, it stays how it is. But if it's 5 or more, you add 1 to the 10th place. So that's what to the 10th place. So that's why this answer will be $7,422.68. Okay, now this is what I mean by using a TI-83, TI-84 calculator. This way, you can have a steady flow without clearing the calculator. That's if you struggle putting all this together in one shot in the calculator, you can do it this way. Okay, now, if you guys have a graphing calculator with you, the TI-83, TI-84, I'll give you like 10 seconds to take it out. This way, you're guaranteed to get the right answers. Okay, because I have one here with me, so that way we can do it together. Okay, give you guys like another 5 seconds or 10 seconds for you guys to take it out. If you guys have any questions, just let me know as we go along, okay? Because I have 2 screens. One screen I cannot see I cannot see the chat, but on the other screen I can see it because I logged in also as a student. Okay, so I'm going to let me see here. I'm going to start. Okay, here we go. So this is my formula, right? So now I'm going to enter in the calculator just the way it is here with parentheses 1 plus 0.0125 times 10 divided by 12, just the way it is. And if you enter it, okay, if you put it just the way it is and you enter, right, you should get that as the answer. Okay, now, how can we continue without stopping the calculator without stopping it? Here's what you do. You're going to press the inverse key. which is on the T83, T84 calculator, is on the first column, on the fourth row. First column, fourth row, there's that key. X to the negative 1 power means, the inverse means that you're going to multiply by the inverse of 1.010416667. So once you press that key, right, then this is what you should see on your calculator. Answer to a negative 1. And then you enter 7,500. And then you enter. This is what the answer should be. You see, this was one steady flow without leaving the calculator at all. So the answer, you see, we got the same answer. But now, right, the answer is $7,422.68. Oh, and then to find the interest, all we do is subtract let me go back real quick. To find the interest, right, we subtract the 7,500 minus the $7,422.68. Okay, that's how much money was an interest that you didn't have to pay. Okay, so that's about what, about $87.32 that she got for putting this in this account here. Okay, now simple interest continue. John received a $10,000 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was 125? Hey guys, interest accrued means how much interest was in was at that 2.5%, 2.5%. So this is the INT, the interest. So now we're looking for time. So here the formula does matter. We have to use this formula here because the INT is a 125. But now we're looking for the time. Okay. So this is the one we're going to be using. And the key word here, guys, is the interest accrued was 125. So the INT is 125. We're looking for time, right? Because it says how long. That's my present value. This is my interest rate, the 2.5%, and which is 0.025, and that's interest accrued. So now all we do is plug into the calculator. All right? So first we multiply 10,000 times 0.025, which will give us 250t. Then we divide both sides by 250, and it should give us 1/2 or 0.5, which means it took us half a year. Okay, that's how long it took. For example, number 3 was half a year. Okay. Now this is compound interest. Okay, I believe I did plenty of examples for section 5.1, which was a simple interest section. Now this section 5.2 is called compound interest. So let me show you the formulas that we're going to be using here. Okay, now I truly believe, guys, that this formula on the right is easier to put in the calculator. Okay, if you notice, the R divided by M is equal to I, and the M times T is equal to N. Okay, now here's what everything stands for. The FE stands for future value, future or maturity value. The PV stands for principal or present value. And again, the R stands for the interest rate per period, converted to decimal from percent. The M stands for number. This is supposed to be of, guys. My mistake, not or. It's supposed to be of number of compounding periods per year. And T is number of years. Now here's where the I is. The I is the interest rate per period. So it's going to be R divided by M. And the N is the number of compound periods or the number of payments. The N is M times T, total number of compound periods. Okay, so now let me tell you what the M stands for, okay, because this is new. Okay, this is what's one of the different variables that we have to keep account of, okay? So now, here's the compounded keywords for the letter M. So it depends on the words what we're going to enter for M or what we're going to input for M. For example, if it says yearly or annually, the M is equal to 1. If the problem states by yearly or semi-annually, the M is equal to 2. Quarterly, the M is equal to 4. And monthly, the M is equal to 12. And weekly, the M is equal to 52 because there's 52 weeks in a year. And daily, it all depends. We know there's 365 days in a year, right? But at times the book might say use 360 for days. I mean, if it's daily. So it depends on the book. But if the book is not specific to use 360, then you're going to use 365. Now there's a last formula, which is compounded continuous. Continuous is a different formula. This is a formula for continuous. The future value, PV, e to the RT. Okay? I'm going to do an example of each one of those. Okay, now, let me see here. So let's do an example. Okay, now, before I do an example, compound interest can be used to invest a certain amount of money without depositing additional money. So, for example, say that you have some money at your house, right? And you want to, put it in a bank, and you want to get interest on that. So if you do that, you don't have to put no money extra. All you do is just put that money in there and invest it without depositing additional money. Okay, so let me show you an example of what they're talking about. Okay, this one here, example number 4. Example number 4, it states you deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much money will be in your account after 5 years? And how much interest did you earn? So this problem here, we can put it like in a real life situation. Okay, let's pretend that you guys have $1,000 in that you have $1,000 at your house. You don't know what to do with them, right? But you don't want to spend them. If you want, you can go to a bank or to an investment firm and tell them that you want to deposit $1,000 in an account, right? And that you want to see how much money you get in 5 years. So they're gonna ask you that the going rate right now is 6% and it's compounded quarterly. So then how much money do you think you can have in 5 years? Let's see if it's worth it. Okay. And again, I like to use this formula because it's easier to input in the calculator. So there's always 7 things that you have to find. You see, 1, 2, 3, 4, 5, 6, 7. From this information, you'll be able to input every variable except for one, what you're looking for. So in this case, we're looking for how much money will be in the account after 5 years. So we're looking for the future value, right? Because we want to know how much money will there be in the future in 5 years. So that's what we're looking for. Now from there, everything should be kind of simple to put at the right place, right? So for example, this has to be then my present value. Remember that I told you guys earlier that the interest rate, the R is where the symbol is, a percent symbol is, right? So all you do is put the coefficient with a symbol. That's my interest rate. But we have to convert it into a decimal, so it's going to be 0.06. Okay, now here we go. This is the M is how many times it's compounded per year. So remember the word quarterly means 4, so M is equal to 4. The T is going to be 5 years. Now, what's the I? The I is R divided by M, right? My R is 0.06, my M is 4, so it's going to be 0.06 divided by 4, which will give you 0.015. Okay, now let me share something with you real quick, guys. Here, this is for the homework sake. If this, right, if the I, for example, you divide the R divided by M, and if it gives you a number that doesn't end, right, like something like point something all the way to the end, right, in your calculator, you don't use that number. Just leave it how it is. Why? Because I believe in my math lab, they want you to round off to a nearest penny. And if you round off too soon, you're going to get the wrong answer by the cents. Okay, and like I said, my math lab is real sensitive on that issue, so be careful. Okay, so but if it's finite, like it is right here, then that's the value for I. The N will be M times T, right? So it's going to be 4 times 5, so it's going to be 20. Okay, so then all we do is input everything in the calculator, right? This is my present value, this is my I, and this is my N. And yes, just let your calculator get the answer for you. So it's going to be 1,346 and 8.855007, right? But we have to round out to our nearest penny. So again, we're going to go here to the second decimal place, right? So this is going to stay the same or it's going to change. How we know if it's going to stay the same or change, we look at the third value here at the thousandths place. So this is 5 or more, then this goes to 6. So the answer will be $1,346.86 after 5 years. So then, how much interest did you earn? So actually, the interest earned is a future value minus a present value. So this was my future value. The present value was 1,000. So you got $346.86, right? Extra, which is not bad, right? If you had that money just laying around, right? So you can keep investing it if you wanted to. Okay, now let's do another example here. Continuous compound interest. Remember, guys, I told you about continuous, right? Continuously, compounded continuously is going to be a different formula. Okay, now I use the same problem, right? In example 4, example 5, but the only difference that here is compounded continuously, and in the previous example, it was compounded quarterly. Just so you know, the more times that the money is compounded, let's see what we get. I believe the more times it's compounded, the more money you're going to get. And the least time is compounded, the least money you're going to get back. So for example, I truly believe that the banks, when you want to invest some money in there, they'll compound it the least amount of times because they don't want to give you that much interest. But when you want to borrow money from them, they're going to compound it higher, right? Because the more times that it's compounded, the more money the bank's going to get. So always, it's always wise when you're going to do something like a transaction at the bank or try to invest some money, you ask them, well, how much is it compounded per year? This way, they know that you know what you're talking about. Okay. So for the for the compound continuous formula, it's going to be the future value, the present value, the R, and the T, because the E is the E function in the calculator. Okay. So here, right, we're looking for how much money will be in your account after 5 years. So that's what we're looking for. The present value is 1,000. The R is 6%, which will be 0.06, and the time is 5. Right. So we plug everything into the calculator. Right. Make sure that with the E function here, that you put in the parentheses, because a lot of calculators, they don't give you this option. They have like a caret that raised to a certain power, and if you put 0.06 times 5, right, without the parentheses, it's going to count it wrong, because what it's doing, it follows the order of operations. So to play safe, you always put it in parentheses. If the calculator gives you the parentheses to start off, then you close it. If the calculator doesn't give you the parentheses, well, then you have to put it in there, and then make sure that you also close it. Okay, but most calculators that you borrow from that you rent it from the lab, they'll give you the when you get the caret for the exponent, it'll be in this form, right? It's going to give you the exponent there, like a little box to enter the exponent. So you can just put 0.06 times 5, and you get the same answer. The right answer. You see, so we got 1349 and 85, right? So I believe the previous one, we had 1346, I believe. So in other words, it's only $3 more. But $3 more, right? $3 more is not that much, right? But imagine, guys, if it was like in the hundred thousands of dollars and stuff, you see it adds up. But anyway, again, when it was compounded quarterly, I believe it was 1,346 and something. And continuous, right? It went up $3. But like I said, it's not much. But the more money that it was, the more it's going to be. So how much interest did you earn? So again, the future value, which is 1,349 and 86 cents, minus the present value, which is 1,000. So the answer will be $349 and 86 cents. Okay. Okay, now let me see here. Let's do another compound interest problem here. Example number 6. Okay, now here it's saying, I want to be earning an annual salary of 100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase at 4% per year, and the starting salary is negotiable. What salary should I request in order to meet my goal? And again, let's make this an example that we can relate to. Okay, let's say that you want to be earning $100,000 in 15 years when you retire. Okay, the job that you're being offered guarantees that you're going to get a 4% increase per year, right? So then, so then they're going to ask you, you can negotiate the starting wage, starting salary, right? It's negotiable. So let's see, for this situation, how much money should you ask for? Okay, that way you'll be guaranteed to get 100,000 in 15 years. So again, this is a formula that we're going to be using, right? So this is the easier one to put in the calculator. So remember, there's always going to be 7 things: 1, 2, 3, 4, 5, 6, 7. But in this case, you want to be earning an annual salary of 100,000, right, in 15 years. So we're going to be looking for the present value. How much money do you want to ask for now? So the future value is going to be my 100,000. My interest rate is going to be 4%, which will be 0.04, right? My M, right, is going to be annually, so the M is going to be 1, right, because it's annual salary. My T is going to be 15, okay? So my I is R divided by M, so it's going to be 0.04 divided by 1, and my N will be M times T, which will be 1 times 15, which is 15. So let's plug everything in, right? There's my future value, the 100,000. There's my I, 0.04, there's my N. So in this case, we're looking for the present value, okay? So what we do here, we're going to enter 1 plus 0.05 to the 50th power is going to give you 1.80943,506, right? Then we're going to divide both sides by 1.80943,506, right? If you notice here, guys, you're going to have to stop the calculator, right? Stop it, and then so we can put 100,000 divided by the 1.809 and so forth, right? So here we have to stop the calculator. So then this will be my answer, 55,526. So you're going to be asking them for for the annual salary to start off $55,526.45 per year. That's what you're going to be asking, and in 15 years you're going to get that much. 100,000, what you're asking for. Okay, now let me show you another way, right? That you can have the easier way to use your TI-83, TI-84 calculator. That you go in a steady, easy flow of the calculator. Okay, so let's come over here. So this is what you're going to put in the right. Enter in the calculator. You're going to put 1 parentheses 1 plus 0.04 close parentheses to the 50th power. If you do that, you're going to get, you should see in your calculator on your screen 1.800943506 in your calculator. That's what you should see. Now, right, you're going to hit the inverse key. Once you press the inverse key, this is what you will see in the calculator. Answer to a -1. Then you're going to enter 100,000, and it gives you the answer. So this is, you see, this is your answer, guys, 55,526.45027. So that's, you see, we got the same answer. And in this way, you don't need the calculator. It's an easy, steady flow, okay? But you have to know that you need to use the inverse key. Okay. Again, the formula in the book uses this formula here. So if you ask help in the My Math Lab homework, and this is the way they're going to show you, okay? But I believe if you come back to this video, or if you want to continue the PowerPoint, it'll be easier because you know what you should get after you do each part here. Okay, and I've been told that some students in the past that they had this class, they went back to this PowerPoint, to the PowerPoint that I sent them, and they were able to get most of the answers right, because this shows them how to get the answer. Okay. So that's it for 5.1, 5, and 5.2. Now this is something from 5.3. This is called the future value of an ordinary annuity. You see, these formulas are the same, but if you notice, like previous, right, the R divided by M takes the place of the I takes the place of the R divided by M. See, the I takes the place of R divided by M, and the N takes the place of the M times T. So this formula will be easier to use in the book. this will be easier for the calculator. Okay, now again, right? You always have 7 things. 1, 2, 3, 4, 5, 6, 7. So what's everything here, guys? Again, this is the future value. These are the payments, and everything else is the same as before. Okay, now future value ordinary annuities can be used to accumulate funds for some time in the future, but you must set regular deposits during that specific time. So in other words, if you guys want to, let's say you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. You want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of those 20 years? And how much money actually was interest? Okay, so again, I'm going to do this example, I believe, on the next slide. And also, here's another example. Let's say that you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure you have enough money in 18 years for your child to attend college. I believe we went over these problems this week, and we had a lot of fun because after I explained these problems, we made it like a real life scenario. For example, students would volunteer and they would say, okay, I want to have so much money in an account after so many years. So I showed them how to I showed them how to use these formulas here to know how much money you can get in the future if you put constant deposits or regular deposits on a specific time. So let's do this first example on the next slide. Okay, and again, we brought it home to our students by saying, put yourself in these shoes. Okay, say for example, after every month you have $1,000 left over, right? So instead of having the money right there at the bank or at your house, right, you can always set up an annuity. And right now, this is pretty much how high you're going to get for interest. Okay, because back in the 80s and early 90s, I believe they used to give you like 8 or 9%, which was 3 times more. Okay, but now they don't pay you that much. They pay you about 3%, something like that. Okay, now so let's see what we need to do here. Right, so that's my formula. So let's see, right? You can afford to save $1,000, right? So we're looking for the future value, right? Because it says how much money will you have in 20 years. So we're looking for the future value. And then also how much interest will you earn? So the payments, right, are going to be $1,000 per month. And the interest rate is going to be 3%. So 3% will be 0.03 as a decimal. The M, right, is compounded, right? So this is every month, right, that you put in every month. So it's going to be 12. The time is going to be 20. Okay. Now the I is going to be the R divided by N, which is 0.03 divided by 12, which will give us 0.0025. That'll be the value for I. The N will be N times T, which will be 12 times 20, which will be 240. So let's put everything in the calculator. Okay. So, right, so this is how you start, right? You're going to enter the numerator first. So you're going to put all that in the calculator just the way it is. And you should get something like 0.82075499953. Then you divide that by 0.0025. So this is what you get. 328.30199981. Then you multiply it by 1,000. So this is your answer here, guys. $328,302. Okay, now again, I'm going to show you how to do that in your calculator with an easy flow, one steady flow. So this is how you put into the calculator. You're going to put the numerator first, just the way it is. The parentheses 1 plus 0.0025 close parentheses to the power of 240 and then minus 1. If you do that, you should see that right, which is the answer here as the example shows right here, the 0.82075499953. And then you're gonna hit the division key, right, because you'll be dividing, and you're gonna enter. This is what you should see on your screen: answer divided by right, which means that you're gonna divide this answer by 0.0025. So then you enter 0.0025. This is what you should see on your screen, right, which is the same thing as what they got here. Then you're going to hit the multiplication key. Then you multiply that by 1,000. But before you do that, once you press the times key, you're gonna see answer times, and then you put 1,000, and that's what you get. We get the same thing. Okay, now, so how much money did you invest? In other words, how much money did you put in there? And how much money did you earn in interest? So let's find out. So how many payments did you make, right? There were 240 payments at $1,000. So you multiply 240 times 1,000. So they'll give you 240,000. That's how much money came out of your pocket, or how much money actually you put into the account. So how much was interest, right? We subtract the 240,000 from the 328,302. So 88,000 and $88,302 was what you earned in interest, right? Which is not bad, right? If you could afford, say, $1,000, that's what you would get. The more money that you can set up, the greater amount you're gonna get in the return of after so many years. Okay. Now let's do example number 8. Okay. Now, and I can tell my students, right? For example, I was telling my students on Wednesday that when, because they're in school right now, right? And most of us get financial aid. Okay, which is good, right? Because we cannot pay for our school. So most of us, we get financial aid. But like I tell my students, you guys are here in school, right, to get a degree and to start making good money. So more than likely, when you guys graduate and start working at a job, right, you're gonna be making very good money, right? Because that's what the objective of going to school is for. So then more than likely, your kids are not going to qualify for financial aid or maybe partial financial aid. So that's why you have to start planning for the future, right, for your kids to go to college. So this is like an example on how to obtain 250,000 in 18 years. So let's read the problem again. You are planning on sending your just born child to college when she turns 18. It can be a he or a she, right? But I just put she turns 18. You want to have 250,000 in an account for tuition in 18 years. How much money must you deposit at the end of each quarter in an account paying 5% compounded quarterly? Well, let's see how much money you need to put in there. There's my formula, right? And those are my 7 things. So now, right, so we're looking for how much money must you deposit at the end of each quarter, right? So we're looking for the payments. So that's what we're looking for. So the future value will be 250,000. My interest rate is going to be 5%, which is 0.05, right? By compounded, my M says compounded for quarterly, so it's going to be 4. My time is going to be 18, right, in 18 years. So then my I is R divided by M, which is B 0.05 divided by 4, which will give us something like 0.0125. My N is M times T, which will be 4 times 18, which will be 72. So let's plug everything in the calculator. Okay, guys, from now on, I'm going to be using the steady flow and the TID3, TID4 calculator, right? So I'm going to show you how to do it. From now on, I'm going to be using the same technique, which is I'm going to input the parentheses 1 plus 0.0125 plus parentheses to the power of 72 minus 1 in the calculator. This is what you should see. Then, right, then you're going to hit the division key. Then you're going to enter, right, this is what you should see on your screen. Then you're going to enter the 0.0125, and then you're going to enter it. So this is what you should see on your screen, 115.67362215. Now, right, so all this part on the right side, this is my answer here, 115.67362215. Now you're going to hit on the inverse key. Okay? Once you hit on the inverse key, this is what you should see on the calculator. Then you're going to enter that 250,000. So this is the answer here, 2161.253334, which runs off to $2,161.25. So that's my payment. That's how much money on the scenario that the person had to deposit every quarter, every 4 months. Okay, now So let's see how much money you actually put in there. So it's going to be right extra. This is extra information. How much money did you put into the account? So you have 72, right? 72 payments at 2,161. So you're going to multiply those. So it's going to be $155,610. That's how much you put out of your pocket. That came out of your pocket, right? So then the rest of the money, right, for the to complete the 250,000 was how much money you earned in interest, which would be $94,390 that you earned in interest. Okay, so this is how you will work this type of problem here. Okay. Okay, now comes the last part of this PowerPoint, which is section 5.4. This is called the present value of an ordinary annuity. Again, these are the same formulas, right? But I prefer to use the one on the right where you have the I instead of the R divided by M. So now this is the most common use of present value ordinary annuities for purchasing an expensive item, such as a vehicle or a house at the present time and making equal payments, including interest for a certain amount of time in years. Okay, so examples. You want to purchase a car. What are your monthly payments and how much will you end up paying? You want to get an idea on the process of purchasing a house. What do you need to know? These are key factors of purchasing an expensive item and payments, especially like a house. You must have a job. With no job, they're not going to give you, the bank is not going to lend you the money. Hey guys, the PV stands for the amount you're going to borrow right now from the bank, right, to purchase an expensive item. The P, that's what it stands for. The present value is the money that you're going to borrow from the bank. So you must have a job, right? No job, no money. They're not going to lend you nothing. Also, you must have very good credit. The higher your credit score, the lower the interest rate you will get. Also, it's always nice to get pre-qualified for the maximum amount of a loan. Hey guys, this is very important here, guys. Okay, I mean they're all very important, but before you see an agent, right, like a real estate agent, when you're going to buy a house, you get pre-qualified for the maximum amount of a loan. So say, for example, you get pre-qualified, right? And say you qualify for a $250,000 house. Okay, now they recommend for you guys not to go max out, so go something like 200 to 225. And then because if you don't get pre-qualified, right, and then if you go look at houses, you're just wasting your time and also the agent's time. The reason for that is because say that you can only afford a house for 200,000. And you're looking at an area that the houses cost more than that. Say they cost like 300,000 to 500,000. You see, you'll be looking at houses that are over your budget. And then once you see something that's in your budget, you're not going to like it. Why? Because what you saw, right, were much more nicer because they were worth more. I mean, they were worth much more money than what you can qualify for. So please, you always get pre-qualified, and even the agent is going to tell you to get pre-qualified first. Okay, that's how they do things nowadays. Okay, now, so then let's see an example here. Say you want to buy a new car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and the loan is for 5 years? How much interest did you pay? Now, 4.2% is a good percent right now at this moment. Okay, if you have good credit, it can even be a little bit lower than that. But if your credit is bad, it'll be something like 6 or 7 or even 8%. Okay, and the higher the percent, the more money you're going to end up paying per month, and also the total amount for the car. So let's do this scenario here. So you want to buy a new car, right? So this is what are the monthly? So we're looking for the monthly payments, right? So then this must be the present value, how much money you're going to borrow from the bank. The interest rate is 4.2%, which will be 0.042. The compounded, right, is going to be 12. Most of the times, when you purchase a house or you purchase a car, it's going to be the M is going to be 12 because they're monthly payments. The time is for 5 years, And the I is going to be the R divided by M, so 0.042 divided by 12 is going to give you something like 0.0035. The N, or the number of payments, will be M times T, which will be 12 times 5, which will give us 60. So this is how you put it into the calculator, okay? So now let me show you how to do it with a TID3, TID4 calculator. So first, right, you're going to enter 1, what's here, which is the numerator. 1 minus 1 plus 0.0035 close parentheses to the negative 60. Once you enter that, you should see something like 0.1891185,031 on the screen. Then you're going to press on the division key, right? Because you're going to be dividing by 0.0035. After you enter the 0.0035 and then you enter, this is what your screen should show. 54.03385,802. Now, right, you're going to hit the inverse key to make it easier. Right, when you press the inverse key, this is what you should see. And then you're going to enter the amount on the left side, which is $26,750. So these are your monthly payments, about $495.06. Okay, now how much money did you end up paying? Okay, let's find out. So right there were 60 payments at $495.06. So you multiply those out, so you end up paying $29,703.60. What was the difference? About $3,000 more or less, right? So you end up paying about $3,000 more. In class today, we did this example, but then I believe we put in like that it was 8% because that person had bad credit or something like that as an example. You end up paying like almost double, I think, double interest. So I think it was like 6,000 something. So again, the higher the interest, the higher you can. I mean, the more money you're gonna end up paying. Okay. So now let's do the last example. Here's about purchasing a house. Here's the goal of every student, I believe, that you want to get a new house, right? So let's put this example here. You want to purchase a $325,000 house with a 30-year fixed rate at 3.9%. What are your monthly payments and how much interest did you end up paying? Okay, now after we get this the monthly payments doesn't include the house insurance and also doesn't include the property taxes. It all depends what side of town you live at. I believe the west side and the east side have the highest taxes that you got to pay. The lower valley, northeast, central, their taxes are not as high as the west side or the east side. Okay, because it depends where you live. But anyway, the property taxes and the insurance are not included here, guys. Okay, so it's just the monthly payment. Okay, so here's my right, the money that you want to borrow, $325,000. The interest rate is 3.9%. And which will be 0.039. The M, which is the payments are going to be 12, right? 12 payments per year. The M is 12. The T is 30. Most of the times, guys, for all loans, they're mostly 30-year or 15-year. If you can pay it off in 15 years, right? It's better because you end up saving a lot of money at the end. And the I will be the R divided by M, right? Which will give us 0.00325. And the N will be M times T, which will give us 360. So we plug everything into the calculator. Okay. Again, I'm going to use the easy flow of the calculator and the TID3, TID4. So we start by inputting the numerator. The 1 minus 1 plus 0.00325 close parentheses to the negative 360. This is what we should see on the screen, which is 0.6890436,901. Then we're going to press on the division key, and then we're going to enter the 0.00325. This is what we should see, which is 212.0134431. Then, right, we're going to hit the inverse key again. So when you hit the inverse key, right, this is what you should see on the screen, answer to a -1. Then you're going to enter the 325,000, and then you're going to enter that. So these are your monthly payments. about $1,532.92. Okay, so these are your payments here. So now, how much money did you actually pay for the house? So there were 360 payments, right? So you multiply that by 1,532.92, which will give you 551,851.20. That's how much you end up paying for the house. So then, how much money did you pay in interest extra? Which was 226,851.20. Also, we did this very same example today in class, and I believe we put like I think like 6% because right now this is low. I mean for the interest rate right now, I believe the interest rate right now is about almost close to 6% or 6.5%. I believe we put like 6.5%, something like that, and we were amazed at how much money we ended up paying. I believe we ended up paying like over $700,000 for the house, which was almost double. Okay, so again, the higher the interest rate, the more money you can end up paying at the end, and the lower the interest rate, the less money you can end up paying. You can actually pay your house in less than 30 years, even though you have a 30-year mortgage. What you do is you pay more money into the principal. This way, you can actually pay the money your house in 15 years or 10 years. We use mathematics for my wife and I when we purchased our first home to actually pay it off in 10 years by using mathematics. Okay, and you guys can do it too. Just have to put more money into the principal. This way, the house can be paid off quicker, and you can save a lot of money in interest. Okay, I believe this is the end of the PowerPoint. And again, guys, if you want the original PowerPoint, send me a text. This is my text. If you want the PowerPoint for my students, I put it on Blackboard but if you're not my student, you can actually get this PowerPoint, and you can, yeah, just send me an email, and I can send it to you. Let me stop sharing.
Mr. Azasi, thank you for presenting for us today. Thank you everyone for joining us this weekend, right before your weekend, and learning about math. I appreciate the good job you did. We'll stick around for a minute or two if y'all have any questions from Mr. Azasi. Like he said, he gave you his email. You can email him as well. We would like to invite you to this afternoon's session, which will be exploring a career in the libraries, hosted by Kristen Sanchez. And then, of course, next week we'll be having Happy Math Hour again at 11 a.m. on March 3rd, Math 1314 and Math 1314, as well as 1 o'clock session for PCC Mental Health Committee. Thank you for coming today, and I hope you have a wonderful weekend.